Hello everyone, I am Karthik from ITA section, roll number 1230. Today on data warehouse, my topic is about Atdm methodology to support the design and implementation of enterprise data warehouse. Let us know what is this Atdm methodology and to support the design implementation, how a enterprise data warehouse works. All this in further slides briefly. Let us dive into our topic. Coming to the abstract, the structure and abundance of online resource usage data restricts the effective and efficient analysis of this data by decision makers. Existing enterprise data warehouse methodologies do not provide sufficient support for the full DW development lifecycle in that support for metadata documentation. Logical design, physical design, and implementation is often neglected. This paper proposes an extension to the triple-driven data modeling methodology to include the addition of a design and implementation phase. The adapted triple-driven methodology supports the generation and documentation of a semantic and a technical metadata that describes an enterprise data warehouse structure at the logical physical implementation level. Introduction. Organizations are inundated daily with vast amounts of online resource usage data relating to the monitoring of services provided by their electronic infrastructure to employees. The efficient analysis of this ORU data by means of a business intelligence environment can facilitate an improved decision making process. An enterprise data warehouse typically forms part of the larger architecture of BI tools that together form an environment which serves an organization by aiding the analysis of process and decision support initiatives through the provision of an data warehouse implementation. Data marts, OLTP, OLAP, metadata, ELT combines and forms a data warehouse. So coming to the background, interest in data warehouse technology has grown significantly since the 1980s. Given that the use of this technology trends and patterns in business processes can efficiently be elected to aid planning towards establishing business strategies. Several studies have proposed methodologies for DW development projects. However, the majority of these studies has focused on the requirements analysis phase and is not comprehensive as they do not extend to the design and implementation phases of this project. Research into the design and implementation phase of a data warehouse design and the existence of the comprehensive methodology is lacking. The most comprehensive of the methodologies reviewed is that of the triple-driven data modeling methodology. Consequently, this methodology is modified to address the identified limitations of existing methodologies, resulting in adapting a triple-driven methodology. ATDM is proposed as a more comprehensive methodology in that it specifically supports the generation of metadata to describe the data warehouse structure across all the phases of the system development lifecycle. In order to measure the effectiveness of the efficiency of ATDM, it was applied to a case study resulting in the collection of measurements that indicate the successful use of a proposed methodology. Findings of the investigation suggest that the use of ATDM might provide a more effective support in the system development lifecycle. EW deals with claims, pharma, EHR, HbA1c, meds, labs, clinical data, social networking, HIE, allergy, etc. EW is enterprise data warehouse. It deals with the several industries in the society. Data warehouse methodologies. Large companies have adopted a data warehouse technology as the standard practice to store integrated and centralized data extracted from different operational sources. This dedicated enterprise data warehouse facilitates the effective and efficient analysis of a business process. The typical architecture of an enterprise DW is represented by different components where data is passed from one component to the next after some critical operation is performed that prepares the data for the subsequent component. The design of an enterprise DW is heavily dependent on the information requirements and the information supply of an organization, and it is important that both of these are well understood by designers. Information requirements have to be refined at different levels of abstraction to obtain an enterprise-wide description of the DW requirements. Business to obtain an enterprise-wide description of the DW requirements. Business requirements are the uppermost in the hierarchy and describe the vision statements, objectives, and the success factors. The business requirements are the elaborated on in a more detail by the user requirement, which are the turn further elaborated on in detailed system requirements. Requirements attribute represents the lowest level of a detailed DW requirements and that describes the characteristics, policies, or standards to which detailed system requirements should conform. For example, how quickly process have to be executed, the maximum or minimum capacity of the data repositories, and the quality and granularity of the data. Design and implementation of a data warehouse. Once the requirement analysis phase has been completed, the DW must be designed, and this process must include the selection of an appropriate approach for selecting the DW structure. This is very important decision since an incorrect approach often results in the shortcomings in performance and scalability. Research studies on methodologies which incorporate the design phase and in particular the selection of a data warehouse structure are limited. The foremost well-known approaches for data warehouse structure selection are the independent data marts, that is also known as IDM approach, and the enterprise data warehouse, that is EDW approach, which we have seen in the before slide, and the data mart bus DMB approach, federated DW approach. The DMB approach is defined as a collection of a dimensionally modeled data marts in which a set of commonly used dimensions are the first designed based on the identification of business requirements for specific business processes. The fact tables may be connected to several dimensions which are shared with other fact tables. Thus, the result of applying this approach, which is proposed by, is usually a collection of interconnected dimensional data marts. The adapted triple-driven methodology. The adapted triple-driven methodology extends the TDM with the introduction of the additional steps to support all the phases of system development and overcome the shortcomings of the TDM. The TDM consists of three primary phases, namely a requirement analysis, design and implementation phase, and the requirement analysis phase consists of three secondary, namely the goal-driven, user-driven, and the supply-driven phase. Two steps were added to the goal-driven phase in order to prioritize the deliverables and to explicitly indicate that a set of semantic metadata is required to relating to the identified business fields, subject areas, and the key performance indicators. Additional processes were added to the supply-driven phase to address the homogenization of the table semantics expert requirement and to explicitly indicate the metadata required to document the primary deliverable of the supply driven phase, the subject oriented data scheme. The several ETL modeling techniques have been proposed based on the Unified Modeling Language (UML), which has become a standard for software system development. By combining the different elements of this ETL modeling techniques, a more descriptive ETL model can be derived which addresses the shortcomings of these techniques. More specially, the ETL modeling technique was adapted to incorporate the formats of data attributes of tables used in the similar modeling technique. Experimental method. Nelson Mandela Metropolitan University has a large network of devices that is used by its students and staff members on several university campuses. The ORU data is logged in several disparate technology service department. ORU data is logged in several disparate operational data sources on which ad hoc queries are issued. These queries can assist with the decisions regarding computer resource needs at different facilities or different campuses. A TDM was applied to the NMMU ICTS case study to enable the evaluation of this proposed methodology, and the experiments were performed in order to compare the traditional methods of the query overview data with the querying facilities provided by the new DW. So coming to the conclusion, the proposed ATDM was successfully applied to the ICTS case study as a proof of a concept, and showed that the ATDM supports the generation and documentation of a semantic and technical metadata that describes a DW structure at a logical physical implementation level. The accuracy experiment results showed a difference ratio tending towards zero, and the conclusion is that the methodology can provide a DW that is accurate. The efficiency result showed that the response times to the total ETL processes was well within the targeted 8-hour period. A positive linear relationship was also observed between the response times and the amount of the data transferred. It was found that the DW is more efficient in processing ad hoc queries even if several ad hoc queries are required to be processed. This is about our topic. Thank you.